Hello everyone and welcome to my WebGL tutorial. This is going to cover modern WebGL, not the old WebGL. That's a very important distinction. So instead of having a long drawn out introduction, let's jump right in. So firstly, we actually want to create the HTML page that we're going to host this on. So it's going to be index.html. And then luckily with my IDE I can actually just type in HTML and then just get all of this basic stuff pre-typed out for me. We're going to call this attempt 1 because it's our very first attempt. Then we want to create a canvas element. Now this is actually what's going to host the application. So let's actually give it an ID as well, and let's call it canvas 1. And then we're going to give it a width of 800 and a height of 600. You know, keeping it basics. This is just going to be a placeholder. It doesn't need to be permanent. And then over here we actually want to include the the script for the rendering engine or the game that we actually want. So we're going to have the source is going to be equal to, and let's just have it main.js. Keep everything very simple. Keep in mind the name that you called this, canvas 1, because it is going to be, we are going to try call it. Let's create the JavaScript file, and then we're going to have the variable canvas is going to be equal, variable canvas is going to be equal to the document.getElement by ID. We want to get that canvas, so it's attempt 1. And now we actually want to get the context from it. So we're going to say vargl is equal to canvas dot get context, and we want to get the WebGL 2 version of it. There's multiple different contexts that you could get, but we're not going to be using any of those. We're just going to use modern WebGL, so that's where this comes in. So now let's actually create just a simple function to create let's actually start with the shaders. Firstly, we're just going to create the Vertex Shader and then a Fragment Shader. Then I'll explain what it actually is. So Vertex Shader is equal to, oh wait, actually this is going to be the source first, and we're going to use these because we want to have multiple lines. We're going to have hash version 300 ES. Please note that this is very important to have this at the top, at the very first line in your shader source. Like, you can't have any spaces or have anything before it, not even a comment or anything. That's just how it works. So then we're going to have the whatever's going to come into the Vertex Shader. I'll explain how this works in a moment. So let's just have position, and we're going to have void main. We're going to have a pos is equal to a position. Wait, actually no, let's not make this complicated yet. Let's just keep it incredibly simple. So we're just going to have this GL position, which this is very important for WebGL. The Vertex, okay, actually I'll explain in a moment. Okay, so I can actually explain it now quick. So basically what we're going to do here is we're saying that we're going to pass through points into the shader, and that's going to be the position points of every vertex. And then the GL position, the way that this is written out, is now WebGL's version of this has to be included in every Vertex shader, so WebGL knows where to position the object. So actually, let's just create a less, just in case we have any mistakes, just created a pause. So we can actually quickly explain like how the shaders work. So firstly, yeah, let's actually just reveal this in Explorer, and then I'll show you how this actually works. So this is actually how WebGL plots the graph. So the origin is actually going to be here in the center, where that's going to be position 0, 0, and then it's just a typical XY graph, where 1, 1 is going to be at the top there, 1, -1 at the bottom there, -1, -1, and -1, 1. So if we actually wanted to plot something on -1, 1, we'd put it over there, and then let's say in this Vertex shader, we actually want to shift up the position by 1. So then it's going to actually, the Vertex shader is now going to, whatever would be printed over there is going to shift it up by one point up to there. And then let's say we wanted our second point to be at -1, -1, then we're going to shift it up to over here as well. And then our next point, let's just have it over there. So then what the Vertex shader then does is it passes it to the geometry shader, which we're going to define as triangles. Like with modern GL and OpenGL, WebGL, we always prefer having triangles. Like it's the easiest to work with, and it's by far the best, especially with the modern way that we do everything. So once we've defined the triangle, then we actually going to send this to the Fragment Shader, which is then going to interpolate which pixels are actually in use. So all of these red pixels are the pixels that's going to be interpolated, and then it's going to run the Fragment Shader for every one of these points. So like let's say if we wanted to pass the position for the Fragment Shader to the Vertex Shader, then how does it know like at what point this is? So it would take all three of these points and it would know how far away it is from each point, and then it would know, okay, it's going to be, let's actually go with over here more. Then it knows it's between 1 and -1, so this is going to be 0.00. And then if we go over here, it's going to be 0.0 and then minus a half around, and the same with every single point. So the Fragment Shader is actually, it's going to be able to handle like the position that's passed through based on the Vertex Shader that's passed through. So let's actually, this is now going to be the position that we're going to be using inside the Fragment Shader. And if you recall correctly, we said that we were actually going to shift it up by one point. So basically this shift, we want to shift it up by 1 point. So we're going to have, instead of that position, we want to have GL position dot x plus equals, let's just have 1. Just so we're clear on like what exactly the point of this is. So now that we have our Vertex Shader source, let's actually add in our Fragment Shader source. So for Fragment Shader source, and then we're basically going to do the same over here, where we want to copy this, make sure there's no mistakes at all in this. One of the annoying things about the shaders is that if there's any mistake in here, it won't compile, but it won't tell you on what line it is. So you just have to be very careful. So firstly, we're going to say what the precision we actually don't really need this, but it's good to have, like, just to say what how we actually going to define the point. So we're just going to have this medium point, and let's just have floats. Okay, and then we're going to have whatever's going to go into the fragment shader from the vertex shader. We're going to have, well, actually we don't need anything yet. Let's just have the out, yeah, whatever is going to go out of this, which is going to be the color. This is the only thing that we ever output from the fragment shader. Is just going to be the color of the pixel. And let's just have it, what's 4, and it's going to be out color. Or let's just go with American spelling. And then we're going to have the void main, and then let's just have out color is going to be equal to we could actually just have like some kind of position over here. Well, let's actually just keep it straight for now. We're going to have Vic. We're going to keep it 0, 0, 0, 1. Well, let's just make this red to start off with. Okay. So now that we actually have the sources, let's create the function that's going to now create the shader for it. So function create shader. We're going to pass through the context, so it's going to be GL. We want to pass through the type, so we're going to say if it's going to be a fragment or a vertex shader, and then we want to pass through the source. And then we're going to create the shader, which is going to be equal to the context create shader. This is now just to create a shader on the actual on the GPU now. And then then we're just going to link it up. So then we're going to define the shader source for this newly created shader, and we're going to link it to the source that we passed through. Then we want to compile it. So then compile the shader. So now the GPU is actually going to try and compile it, and we could check for errors, but I'm too lazy to do that now, and this is just something that you're probably even going to forget, especially in the beginning. It's probably very important to do that usually, but I just want to keep this simple, so we're not going to focus on error handling yet. So then we want to return the shader. Okay, so now we can actually create our vertex shader and fragment shader. So let's create vertex shader. It's going to be equal to create shader. We're going to pass through GL. We're going to pass through GL dot vertex shader, and we're gonna pass through the shader source, which is going to be vertex shader source. So okay, now we'll have the vertex shader. Now we just want the fragment shader. So fragment, and this is going to be fragment and fragment. Okay, so now that stuff is defined, we actually now want to create the program, the shader program from our two shaders. But let's actually just have a function for this, because we could also want to use multiple shader programs in our application. So let's start off function create shader program, And in this, we actually also want to pass through our context. We want to pass through our Vertex Shader and our Fragment Shader. Okay, so our shader program is going to be equal to the gl.create shader. So this now actually creates the create program. So this now actually creates the program on the GPU. So we can now have a reference to it, but we now just need to attach the fragment shader and the vertex shader. So let's just have gl.attach, just attach shader. Hopefully I'm spelling this correct, because otherwise it's going to be a bit of a problem. So we want to have the shader program, and we want to pass through the vertex shader. And then we want to do the same for the fragment shader. So gl.attach shader program and the fragment shader. Okay, and then we actually want to link the program to our application. So link program. So now this is basically saying, okay, this is the shader that I want to use. We only have one, but this is just confirming. It's going to be shader program, and just make sure it's a capital P. Okay, so we could also handle errors over here. It would be best in the future, but not going to do that now. Keeping everything super simple. Though I say I'm keeping everything simple, this does also include the fact that I'm also trying to get everything done properly the first time. So now let's actually create our shader program. So our shader program, let's have it lowercase. Shader program is going to be equal to our create shader program. And we're going to pass through the GL context, we're going to pass through the vertex shader and the fragment shader. And then, okay, so now we've actually got our shader program. Fantastic. So now let's actually just create some kind of, well, we want to create some kind of object, and then we want to define the vectors. So in this example, we're just going to create a simple triangle. So we're going to have the 3 points for the triangle, but first we want to get this location. So it's going to be a pos. So now we're going to have the variable pos for position is going to be equal to the gl.get attrib location. This is just to get the location of where the attribute actually is in the shader program. And this always gets it from the, or it should always get it from the vertex shader, I think. I've never actually tried getting it from the fragment shader. And then we're going to say what it is. So it's a underscore pos. The a is just like to say that it's going to be that it's an attribute. There's also, we can also pass through a uniform, which is almost like a standard variable that's always going to stay the same and only change when we explicitly, well, yeah, whenever we change it. And this is basically going to be for every point, if that makes sense. Okay, so now we actually have our position. So now the way that we actually pass data to OpenGL is that we actually need to send through a we actually need to send our information as a buffer. So we're going to actually bind, so we actually need to create the buffer first. So we're going to create pos buffer, and then we gl dot create buffer. So now that we have the buffer, we want to bind it. Bind, and it's going to be an array. So it's a array buffer, and we're going to send through the pos buffer. So now we've bound the buffer. So let's actually create our points now. So we said that we wanted our points, well, let's actually just call them vertices, because that's actually what they are. And wait, wrong key over there. Okay, and our vertices are going to start at, it's going to be, we're going to have -1, 1, -1, -1, and we wanted 0, 0, wait, -0.5. Sorry, I'm just trying to, yeah, let's go with those points. So now this is basically going to create a triangle that should be all the way on the left, but remember our Vertex Shader is going to move it 1 to the right, so that we're going to actually have wait, yeah, no, just ignore that. But anyway, so now we know that we're going to shift it 1 to the right. So let's actually create the add in the buffer to it. So we're going to have gl dot buffer data. We're going to pass through the gl dot array buffer. It's going to be a float, but we have to explicitly say that 32 point array, because this is how yeah, this is just how OpenGL works. It needs everything to be explained explicitly. Positions, wait, we just said pos, right? Yeah. And then we actually want to include oh yeah, just GL static draw. So static draw is just to say that, okay, we don't want to change it very often. Even though we're shifting it to the right, that's actually not changing the vertex position. That's just the shader that's actually changing the position. Even if we had to say like the position of the object is going to be 5 up, or like we want to rotate or anything, the points are always going to be the same. We're actually not going to change the vertices. We would only change like other parts of the application, of the object. Sorry. Okay, so now the way that modern GL actually works is we actually have what we call VBOs, which is the vertex buffer object, and VAOs, which is going to be the vertex array object. And now every VAO actually contains a bunch of VBOs. And now a VBO can basically be like the position, the texture coordinates, basically a whole bunch of different things. It's almost like creating a new object. And now the VAO is that object, and the object has a bunch of attributes to it, which is going to be the VBOs. So instead of like working with multiple VBOs for every object, we're just going to work with a single object. This is one of the things that modern OpenGL has actually introduced. So let's actually create our VAO, which is basically just the object that we're going to be using. We can have gl dot create array, vertex array, I think it is, vertex array, and then we want to actually bind it. So we want to bind our vertex array to the newly created VAO, Vertex Array. Don't know why I put in a space over there. Okay, so now that it's bound, wait. Okay, now it's bound. So now that the object is actually bound, we can actually enable our VBO. So let's enable the vertex array, and that's going to be our position. I think it was. Yeah. Okay. So now that it's enabled, we actually want to have we want the graphics card to know how we want to interpret this data. So let's actually just start off with the iteration. This is basically going to say like how big the or how many points we want for every vertex. We're only going to have two-dimensional, so we're going to have a 2. Then we want to say the data type is going to be equal to, we wanted a float. Okay, variable norm is going to be false. It's unimportant for now, but just know this is going to be like it's unimportant for now. Just for now, we're just going to have everything. We're going to have it as false at all times. Okay, the stride. This is basically to say how many points we're going to skip. Remember, everything over here is just on these vertices. We don't want to skip any. We don't want to we don't want to have any offset or anything. Offset is also going to be equal to 0. We just want to read 2 points at a time. So it's going to be 3 vertices. Oh, yeah. So it's going to be that is 1, 2, and 3. And so we're going to read for every 2. Okay, and then we're going to have GL dot vertex attrib pointer, and we're going to put in the position, the iteration, the data type. Do we want it to be normalized, and the stride, and the offset. Okay, so now that we have all the information, now our graphics card actually knows how to handle this. So now it's fantastic. Now we actually have our object. We've told the graphics card how we want to handle. We gave it the shaders. Everything is now updated. So now let's actually just draw our triangle at long last. So we're going to create the viewport. This is now just going to be how we want it to be seen. So I think it's lowercase. I hope it's lowercase. Okay, so we want the this is basically just saying of the canvas that we wanted to start from 0, 0 all the way up to 800, 600. So we can actually just hard code this for now. 0, 0. You could have like canvas.getAttribute width and canvas.getAttribute. Actually, let's just do that. So it's canvas.getAttribute width, and then canvas.getAttribute height. So now we have the width and we've got the height. And then we want to always clear everything. So almost like basically refreshing. So gl.clear color, the American spelling. It's so annoying, but I'm kind of almost getting used to it now. Gl.clear color buffer, but you don't really have to understand what this does yet. You can just know that it's basically just a refresh. Okay, and then now we want to use our shader program. So use program shader program. Then we want to bind it. GL bind. Yeah, we want to bind our VAO now that we're using the shader, so that shader has access to it. So Vertex Array, the VAO, and now we want to just draw it. So it's going to be GL dot draw array, draw arrays. And we actually want to have, we want to draw it in triangles. Like this is the default. Like almost everyone will always have triangles. I don't know why it's not showing up here. Okay, well, so let's just type in triangles. And then also the offset, basically where we want to start. We just want to start from 0, and then the count. Oh right, this is just going to be like how many vertices there are. So it's basically going to be this array divided by the iteration, which is just going to be 2. So it's just going to be 3 vertices. But it's also, yeah. So it always has to be a multiple of 3 when it's triangles. So it would have to be 3, 6, 9, or whatever. You could have, like, I could probably type in 4 over here, but it would only read the first 3, and it would still work, but it's best to just avoid that. Okay, so let's actually see if this now works. I am really hoping that it does, hoping for my life over here. Now, one thing that I always like to do is always like to open it up in Firefox specifically. Why Firefox? Because this actually tells me errors a lot better. Canvas is null. Okay, so why would canvas be null? Let's see. Canvas 1, is that what we actually called it over here? Oh, we call it attempt 1. Okay, so it's canvas 1. So let's save that again and refresh. Okay, and let's get inputs text as a function. Wait, where is this? Oh, oops. I don't know what happened over there. Oh, right, we don't want ms get input the text, whatever that was. We just want get context. So save that. Try run it again. You gotta love this. Errors all over. Oh, wait, where's my console now? Oh, there. Okay. So now we know over here the link program must have a compiled Vertex Shader attached. So for some reason the Vertex Shader is not compiling. So the Vertex Shader, what in the Vertex Shader is wrong? Oh right, this is very important. OpenGL does not like it when you just have something like this. You always want to explicitly say what the full type is. Even though with Java, JavaScript and all of that, you can always just say 1. You have to say 1.0 in this. You could also do like 1 point, I think should work, but that's one error. Now for Fragment Shader, okay, so Fragment, I think it's actually there's the same issue. Okay, and must have a compiled fragment shader attached. Okay, so the fragment shader is still having issues over here. So what is the issue? Out color. Oh right, we want to say vec4. Sorry about that. Very important to say it's a vector 4. And now let's try it again. Vertex fetch requires vertex number 2, but attributes only supply 0. Where was this? Oh, okay. Draw arrays. Vertex fetch requires vertex number 2, but attributes only supply 0. Oh right, because I think we sent through the position, but we never sent through, did we? Oh yeah, we just sent through the position of the attribute, and we actually want to send through the vertices over here as the float. So let's actually try it one more time. Okay. And fantastic. This is now our triangle. As you can see, it's shifted up to this point over here. Remember we said that we shifted it from this point over here, we shifted it to there. This point that is meant to be there shifted up, and there was also another point over here that we shifted up over there. That's basically where the fragment shader comes in. I'm actually just going to put this to the side over here so we can keep watch of it. Okay, so now let's actually change a few things over here. So this was actually where we added the position. So what we can actually do is, let's actually get rid of this line, and you can see that this has been shifted up. This is what the Vertex Shader is actually doing. But now the Vertex Shader is just the given points. The Fragment Shader isn't actually doing anything other than defining what the color should be. So we can even have it here where we want this to be 0, and let's have this 7. So this should be quite high green. But now what we could actually do is, because we want to have something, let's have a attribute that goes out. It's going to be a vec4. And let's have it basically, let's have it color. Okay, and so our color is going to be equal to our A position, and then the input over here we can have in color. So now we actually have something that came from the output of the Vertex Shader to the input of the Fragment Shader. And if you recall correctly, it's going to interpolate the data between the points. So this point is, so you will actually see it now. So instead of having it the color over here, we're now going to save the color as the position. What's happening now? Let's have it compiled. So the out vec4 color is A position. let's just call it coal for now, just in case that might have something to do with it. Just gonna save this again. Okay, so it has something to do with, save this again. Okay. So that's still fine. Oh, right, we got to specify the file type, so it's going to be a vec4. It's going to be color. Confirm. Okay, fantastic. And now color, and let's close this up, save. No, we don't want to save this. Render, and now you can see it's interpolating because it knows where the position is, so it's actually changing over to there. And now what you could also do is you can have something where you could also say the out color dot y, which is one thing that this also does is for vec4 you can say dot x or dot y or dot z. You could also do red, green, or blue. So let's actually just have blue is going to be equal to, and let's have it equal to the green color of it. So now it's equally blue as it is green, which is going to give it this turquoise color. And that's the basics. So now you have something to show. So I hope this helped. I hope this cleared up a lot. And I will see. I'll put the code up for this on GitHub. You can check the link below. And unfortunately, I had quite a few errors as well. But now you also have an idea of how to solve those issues. So I hope this has been useful, and enjoy.